Let me give you a couple of ways to do this question. Right, a really nice approach, if you spot it, is similar triangles. But it's not the most obvious similar triangle situation you'll see. But this red one here is going to be similar to this blue one. Because they're parallel lines, so you can see that this is the same as this. In fact, because of the symmetry, like all of these are the same, and then these two will also be equal. So if I just draw the triangles out over here in the same orientation, and of course that one is actually the same as this one, then I've got a length of 5 here and a length of 3. And so my scale factor to go from here to here is 5 over 3. So if I now call this height x, then, oh yeah, and to go this way, I'd be timesing by 3 over 5. So that means that this height is going to be 3 over 5x. I can add them together. That'll give me 8 over 5x, the total height, and I can see that's going to equal 2. So x is equal to 10 over 8 or 5 over 4. And that's what I need. I've just worked out this length here. So I've just got to double it. So I've now got this shape here. The height is going to be 5 over 2. And its base is going to be 5. And if you want to work out the area of such a shape, it's actually, I've got the diagonals, and you just times the diagonals together and divide by 2. So it's actually going to be 5 over 2 times 5 over 2, which is 25 over 4, which ends up being 6¼ 6.25. So our answer is B. Why can I just times the diagonals? Because actually, if I create a little rectangle around it, we can see that I've just found half of a rectangle. Okay, because this is half of that little rectangle on the bottom left, and similar for the others. So that will always work. Nice. Let me show you one other way you could do it. So I decided to say, right, I'm gonna use straight line graphs here. This is gonna be the origin. Oh, then that line is going to be y equals a half x because I'm going along 2 and up 1, for example. And I'm going to try and find this point of intersection. That's my aim. So if I look for this line, I can see that the gradient is going to be minus a half because I'm going along 2 and down 1, plus c. And then it's going through the points 5, 0, for example. So 0 is going to be minus 5 over 2x plus, sorry, 0 is going to be minus 5 over 2 because I'm substituting in x equals 5 plus c. So c is going to be 5 over 2. And that means that y is equal to minus a half x plus 5 over 2. I can now set them, I can set this equal to this to find out where they intersect. So a half x equals minus a half x plus 5 over 2. X equals 5 over 2. And that makes sense because it's a halfway between. It had to be because of the symmetry. But what it now allows me to do is work out the value of y. And that's going to be a half of it, so 5 over 4. So again, I've worked out this distance here. I could double it, so this is 5 over 2, and I'm back in the same place. I can use the diagonals. So yeah, it's one way of doing it without similar triangles. But yeah, both really solid methods, I think. Well done.